Welcome to section 4. In this section we are getting started with DynamoDB. First, we are going to take a look at NoSQL Database Principles. Then I will introduce you to DynamoDB and we will be defining these DynamoDB tables using Serverless framework. By the end of this section, you will be able to manipulate DynamoDB data from an AWS Lambda. So let's get started. Let's start with the NoSQL Principles. In this video, we are going to take a look at relational databases and NoSQL Principles. This video will give you a brief introduction on NoSQL databases. This is not a database course, but I think it's important to start from what is a relational database to move to what is a NoSQL database. This is just a brief recap of the most important concepts of this database. A relational database is organized in a relational model. That's why the name. A relational model organizes data into one or more tables. They are called entities or relationships, with columns and rows with a unique key identifying each row. Each of these rows is an instance of that type, and each column represents an attribute. Also, relational databases has keys. Keys can be like student in the student table, a student ID, or it can be composed by two keys like course ID and student ID. In this example, we have three tables: students, courses, and enrollments. And then enrollments is the relationship between course ID and student ID. And to identify a unique enrollment, we need both the course ID and the student ID. Many students can be in a course, and one course will have more than one student. To manipulate and get this data and query it, we will be using SQL. That's why these databases are called SQL databases. Relational databases have transactions, and these transactions have some properties. These properties are dynamicity, when the transaction is all or nothing, so we will update all the fields on a relationship, or none. Consistency, it goes from one valid state to another. Isolation, it means that executions are concurrent and not two executions get overlapped. So if we are doing an update on one object, then another, it will happen first one and then the other. So then the execution will be sequential and these two different executions cannot overlap. And durability, it means that after a transaction is committed, the data will remain permanently in the database. There are some problems with relational databases. The biggest problem and the reason why NoSQL databases were born is the problem with scaling up and with big data. That relational databases are not very good at scaling up, and that's one of the biggest problems. And when we are handling a lot of data, then we cannot use them and they're very fragile. Then also it's hard for developers because we need to have this language that is SQL. And we need to, and the definition that is in the tables is very different from what is the objects in the code. So developers find it pretty hard. They need to have some layers of abstraction in the middle in order to manipulate this data. And because of the hard schema, then the data cannot change a lot. So if we want to add a new field, then we need to modify the table. Or if we want to have data that is variable, so if in the student we want to have sometimes the name, the email, the address, but sometimes we don't, then it becomes a little bit harder with relational database. Benefits of relational database are that the atomic transactions, the ACID transactions in general are very good and very important, and one of the best things of relational databases. The hard schema is good because you know what is in the database and you can manipulate it easily, so it's a good and a bad thing. And then because of SQL, it's easy to query. NoSQL databases are not only one type of databases, and it represents all other non-SQL databases. There are many kinds of them. In this video, we will focus on one kind of NoSQL databases that are the key value databases. These are like Dynamo, so that's why we are focusing there. But there are other types like GraphQLs and many others. So in a key value pair database, data is not modeled using the relational database anymore. Data is aggregated in another way. So now we will have students, we have a student ID, it also have a key, and it will have a name, an email, and it will have, for example, all the courses that it's enrolled. We can have these type of things in here. We have the key, and then we have the value. So that's the key value database. In a key value database, the schema is not existent, so some students might not have an email, and some students might have a social security number, and we can add that information as we want in our database. There are some problems with NoSQL databases, replication and logical consistency issues, because these databases will scale very well. They will grow very big, and then replication can be a little bit problematic, and consistency as well. But in general, good database engines will take care of handling this. And then because of the lack of schema, it's kind of hard to manipulate the data because you don't know what you're going to get back from the database in some cases. And because there is no SQL, sometimes it's hard to query all the data, and because of the way that the database is laid off, it's quite hard to get all the data. Benefits of NoSQL: it scales extremely well, some engines better than others, and that's one of the biggest things, that it supports a large amount of data. It has a light schema, no schema at all, so you can be very flexible on what you put into the database. And it's very easy to develop because, for example, a lot of these databases are JSON based, so you can just basically put JSON and get JSON back, and that makes development pretty straightforward. So to wrap up, let's talk about what is the differences between relational database and NoSQL database. Relational database has a hard schema, and NoSQL databases has light or not schema at all. Relational databases has atomic transactions, and NoSQL databases has eventual consistency, meaning that in some point the whole database will be consistent, but not all the time. Relational databases scale up, meaning that the machine will grow faster and bigger, and NoSQL databases means scale out, so you can have horizontal scaling, meaning you can have multiple instances of the database and it will handle it very nicely. And relational database has this impedance mismatch, that means that the way that the things are stored in the database are not the same way that the code is handling those things. So then for developers it's kind of hard to do this match between what is in the database and what is in the code. And NoSQL databases in general handle more like these object-oriented objects, and what is in the database in general are like more like objects that we will have in the code.